Welcome to the Health Feeds Performance podcast, where we believe that whole body nourishment is a requisite for athletic success. I'm your host, Ian Craig from the Centre for Integrative Sports Nutrition, and today I'm joined by a friend and colleague, Heidi du Preez. She's based in South Africa, basically where that second picture is behind me, in Noordhoek in the Western Cape. So Heidi is a professional scientist, registered professional scientist, specializing in nutritional biochemistry. So today the topic is sudden death syndrome in athletes. It's a bit of a sobering topic, but because it happens, I feel it's an important topic to delve into and explore. Is it by chance that happens? Is it just our genes, or is there a bit more to it? And based on the complexity of human physiology and health, I would opt for the latter one. So I'm going to explore that with Heidi now. So Heidi, thanks a lot for joining me. I'd like to just start by asking you to give us an introduction. Who are you? What do you do? And what's your passion? What's your interests?
Hi Ian, thanks for this lovely opportunity to present with you tonight in this podcast. My background, I would say, is rather unconventional, but I think it helps me to think out of the box, and I work very interdisciplinary. I think it starts at school. I loved cooking and baking, and basically loved food. And apparently I was good in science, and putting the two together, I ended up studying food science. It's a 4-year BSc agricultural degree. A lot of people see a food scientist as just a glorified chef, but actually it's a very diverse subjects, from engineering through to advanced chemistry, biochemistry, microbiology, anatomy, physiology. I did my master's degree when I was 25. And worked 6 years within the food industry. Then I followed my free spirit to the UK as on a holiday working visa. And there I started to become interested in health, in sort of mainly natural health. And with my background in biochemistry, I realized that nutrition forms the basis of any health regime. But nevertheless, in that time I became extremely ill because I lived under the bread line. And I returned to South Africa, and then it was a quest for me to find my own answers to health. And I realized that God was taking me through the university of life. You know, you learn the most through experience, through going through illness yourself. I think that also gives me the empathy and sympathy to work with my clients today and understand what they're going through. And finding answers for my own health, I started to help other people, and I've been basically 20 years in clinical medicine. And it brought me to a point where I'm currently busy with a PhD in clinical medicine. And I specialize mainly on sulphur metabolism, so biochemistry pathways, but with a very strong emphasis on a specific pathway.
Thanks, Heidi. And I've seen you present several times in sulphation, and sulphur is a really important building block to the human body, or all the way through nature. But it's something that it's actually a very niche area. Not many people study it, not many people understand it. So can you begin that journey with us? What is sulphation? How does the body metabolize sulphur, and what's the relevance of it in this discussion?
And I'll explain sulphur metabolism initially, and then it will go into sulphation, where my main focus will be. And the focus of this podcast is on sudden death in athletes. So just to keep perspective, the most sudden death mostly is because of a heart attack. But it's very important to have this background, understanding what's leading up to a heart attack. And I do it mostly now and look at things from a perspective of sulphur metabolism in this specific pathway. So that's why I'm going to give a lot of background information first, and then we're going to go into how that relates to athletes and then to sudden death. But it's a very complex pathway that I'm going to try my best to simplify. And then Albert Einstein said, if you can't explain it well enough, you didn't understood it. Or if you can't explain it simply enough, you didn't understand it well enough. So I'm going to try my best and to explain a very complex pathway in a simplistic way. The pathway, the complex version of the pathway is going to be on the website. So anyone that wants to go into more complexity can then review the pathway on the website or follow as I go through the presentation. Now, just to take a step back in biochemistry, or to understand the human body is extremely complex. We'll never understand it all. We'll never know it all. But just to realize that there's about 70 trillion chemical reactions that take place in our body every single second. We don't think of ourselves as this energy combustion process and all these molecular reactions taking place. And every reaction needs a specific enzyme to catalyze that reaction, to make it happen. And every enzyme needs certain vitamin or mineral. We call them the coenzymes, cofactors. So just to bear that in mind, it's all these chemical reactions taking place. But I'm going to talk about sulfur metabolism, which is but one pathway of all these trillion reactions taking place all the time, and to realize that they happen in every cell. But this specific sulfur metabolism pathway is mostly also pronounced in the liver because it plays such a big and important role with detoxification. Now the pathway starts with methionine. Methionine is a sulfur amino acid. So proteins are broken down into the smallest unit is amino acids, and methionine specifically contains sulfur in its structure. Then methionine will convert through to cysteine. First to homocysteine. The first part of the pathway we refer to methylation. And then from homocysteine to cysteine, which is referred to as sulfur transsulfuration. And then cysteine can convert to glutathione or then to inorganic sulphate and taurine. So the last part of the pathway is sulphation. Now methionine is an essential amino acid, which means the body can't make it. So methionine can convert to cysteine, taurine or sulphate. So the body can make cysteine and taurine from methionine. But methionine we need to get from our diet. And the most important or the best source of methionine, the sulfur amino acid, is animal protein. So in this podcast, the emphasis is going to be on cysteine, how it converts to glutathione, but then also down into sulphation and taurine, with a main emphasis on specifically sulphation.
Okay, so that's a brief version. As Heidi said, the pathway will be on the webpage specific to this podcast so that you can have a review of that. What's the significance of sulphation? I mean, I think that's a multifaceted question, but I know you're ready to kind of dive in there and talk about it, Heidi. It's one pathway, but you've talked about so many reactions happening in the body. Why is this pathway so important to our human health?
Okay, like I say, from methionine, it's converted to cysteine and then down to sulphate. So what makes sulphate so valuable? Every single cell in the body has a layer around it, surrounding it. It's proteins and carbohydrates. It forms like a hair-like structure, like a web, a net around every cell. We call that the glycocalyx. Glyco stands for sugar, calyx, coating. So it's this sugar coating surrounding every single cell. And that needs to be highly sulfated. So this sulphate is highly bound within this structure around the cell. It's a very unexplored area of science, specifically sulphation, but also then it's also called glybiology. And then this structure surrounding the cell, because it's a very delicate, fragile layer, so it can easily degrade and then it's change all the time. But it's also the degree and the position of the sulfate groups. So it change depends on where the sulphate group is binding in this layer of carbohydrates and protein, this mesh around the cell, and also the degree, how many of the sulphate groups is bound. That will determine function. And it's like I said, it will all depend. So we need to keep in mind, where is the sulfur coming? From where is it coming? And what's gonna deplete it and what's gonna contribute to sulfur? Because I want to optimize that protection around each cell because it has so many different functions. Now, sulphate has a negative charge, it's 2-, and that means it's hydrophilic. It will draw moisture, water, and that helps with lubrication. And the first place in which it's very important for athletes is in our joints. Our joints has a lot of this glycocalyx and sort of sulphate bound within that mesh and network, which helps with that lubrication. And especially with high impact sport and on our knees and other joints, it's very important to make sure that that is adequately sulfated and for joint health. But then also for gut health, it helps with motility through the gut, so also with lubrication, and then also barrier function. So when that layer is, this glycocalyx is around every cell, but it's especially pronounced in our epithelial cells that's lining our airways in our lungs, and then our endothelial cells, which is in our whole circulatory system, in our lymphatic system, and then in our blood vessels. So everywhere this barrier layer, this glycocalyx, this sugar coating layer. And then it's the degree of the sulphate and where they bound, which will determine function. So also barrier function. Mostly with a leaky gut, there's a focus on the T junctions that's compromised. But it's first this glycocalyx layer that becomes compromised and degraded, which will affect leaky gut. So it's the barrier functions and protection. It helps with motility, lubrication, but then also immunity. So microorganisms also, like bacteria, yeasts, and parasites, have a negative charge surrounding them. And if a cell or these barrier functions is highly sulfated, sulfate has a negative charge, they will repel each other so that microbe can't move through this layer. So it plays a very important role in immunity. I did a lot of research on COVID. So in the lungs, the SARS-CoV virus also has a negative charge, and it can't go through this layer to bind into the ACE2 receptors if that is intact. So it's really our first line of defense. Our innate immunity plays an extremely important role. But then in athletes, we have high metabolic needs, and under hypoxic conditions. So I have said methionine convert down to cysteine, and that then will convert to glutathione. But under exercise and hypoxic conditions, cysteine will convert to hydrogen sulfide, which is then serves as an electron donor in the energy pathway. So it will then serve as an electron donor to convert to ATP. So as an emergency electron donor during hypoxic conditions. So we can look at exercise as when we exercise, there's a lot of free radicals form. It's like having a car. If you drive that at high rev, there's going to be a lot of exhaust fumes. So with exercise, we know there's a lot of free radicals forming, reactive oxidant species, which increase oxidative stress in the system. And for that we need an antioxidant. Glutathione, we know, is a super antioxidant that's then going to help to bind and inactivate the free radicals. But if cysteine converts then preferentially to glutathione and hydrogen sulfate under endurance exercise conditions, that will negatively impact on sulphation because there's only so much sulfur available, cysteine. So it's either going to convert to glutathione or then hydrogen sulfate, and then there's less to convert to sulphation. So we need to see that homeostatic balance and keep that in mind all the time. The sulphate in that glycocalyx layer also plays a very important role to modulate inflammation and coagulation. So I said in our circulatory system, in the blood vessels, in the endothelial layer, it forms that protective layer. Now, if we have that intact layer with lots of sulphate groups, it helps to modulate inflammation. So if there is like one cytokine or one toxin, say there's one toxin, one microbe that try to go through that layer, the immune system can react and target and inactivate it. But if that layer is compromised, if there's not a lot of sulphate bound in that layer, then there's many of these microbes and their toxins and other toxins that can leak through, and then it spark inflammatory response. The immune system becomes like a wind-up soldier that just shoots in all directions. And that's basically a cytokine storm or a hyperinflammatory response. So it plays a very important role in inflammation, but also coagulation. So it helps a lot of blood, for a lot of blood and clotting factors that binds to these sulphate groups, or then so that the platelets don't bind into the endothelial layer and cause coagulation. So on many different levels, and we need to keep in our mind is just to see it as a sulfur pool that maintain this homeostatic balance. And it's, in simplistic terms, that is.
Thanks, Heidi. Okay, so I've literally listed down things you were talking about. Sulphation's involved in the gut, mucosal membranes, gut-based immunity, lung tissue, the immune system, especially with this negative bond repelling microorganisms, metabolism for athletes, glutathione. So just to emphasize for everyone, glutathione is a very, very strong natural antioxidant system within our body. But we need to make it, and this is part of what Heidi's explaining here. And then obviously inflammation. And inflammation is part of exercise, it's part of injury, and it's also part of illness. So these are things that athletes are challenged by, every day when they're training hard. So let's talk about what we can do about it. What can we do to support sulphation? And the thing I love about nutrition, you've got biochemistry, but then you need the feeders of that biochemistry, and nutrition does that. So in a way, as practitioners, can almost steer the biochemistry within our bodies in the way that we want. So can you just go into some nutritional aspects that can improve sulphation capacity and other life factors as well, Heidi?
Yes, like you say, I think it's important to realize what's contributing to these sulphate groups, because we've realized how important they are in the system. And it's like you said, the dietary factors is key, is number one. And if you understand these biochemical pathways, you would realize that food is our medicine, because that is what's keeping the body in all these billions and trillions of chemical reactions going. That is the substance and the basis. So if we look at this pathway again, so the most important source is the sulfur amino acids, because the macro building blocks is the amino acids. So it's methionine, cysteine, and taurine. And like I said, the essential fatty amino acid, methionine, we get mainly from animal protein, because animal protein is a complete protein. It contains all these amino acids. And it's high in sulfur amino acids, so methionine. But also something like the amino acid taurine, although methionine can convert to cysteine and then to taurine, taurine we can also only get from animal protein. So that's why animal protein is so important in our diet. And also it's a good source of the amino acid cysteine. So like eggs, dairy, meat, fish, and chicken, because that's sort of the baseline. But a lot of vegetables is also high in sulfur, like we know our cruciferous vegetables and our allium vegetables. So cruciferous, high in sulfur would be your cauliflower, cabbage, kale, broccoli, Brussels sprouts. And if we look at the allium vegetables, it's our onions, leeks, garlic, chives. But in vegetables, through cooking, we easily lose sulfur. So that's why animal proteins still remain, because that sulfur is bound within that amino acid structure and is then better utilized, the mineral in our system. So this talk we focused a lot on sulfur as a mineral, but there's a lot of other micronutrients, which is also extremely important in this pathway. So one of the important cofactors is molybdenum. It's not a very well-known mineral, and that plays a role in converting sulphate being oxidized into sulphate. So it's your sulphate oxidase enzyme that depends on molybdenum as a cofactor. And molybdenum we get mainly from our pulses. So that's our beans and lentils and chickpeas and mung beans, which is also, so our animal protein is just as important in our diet. And then another important cofactor is histidine. So the conversion of cysteine through to taurine or sulfate, that enzyme, cysteine deoxygenase, also needs histidine as well as sulfate oxidase. Needs histidine, and that we find in whole grains and nuts and seeds and in animal protein. So what this pathway has taught me is that we really need a varied, balanced diet. We need the animal protein, but we need the vegetables, we need the pulses, and we need the whole grains in our diet. Other important minerals and vitamins is iron and zinc, vitamin B12, which we know we mainly get in vitamin B12 only in animal protein, and it's also like red meat, the best source of iron and zinc. They play a big role in the whole pathway, especially also then in methylation. And then vitamin B6 is another very important cofactor, which is in animal protein, eggs, bananas, and avocado is high in vitamin B6. Plays a role in our CBS enzyme that's responsible for the conversion of homocysteine down to cysteine, or then from cysteine deoxygenase, cysteine through to taurine or sulfate. And then folate and methylation cycle is green leafy vegetables. So a varied whole food diet, it's very cliched, but we can't get away from that. It's food as our medicine. And then an athlete has a high demand for energy, high combustion processes going on, so they can supplement with extra sulfur. A very good sulfur supplement is NAC, so N-acetylcysteine. So that's cysteine amino acid that we can supplement with, or then MSM is your methyl sulfonyl methane. It's an organic sulfur donor. And the liquid form is DMSO. It's also very good. Or there's lots of sulfur supplements with sulforaphane. That's basically your cruciferous vegetables in the powder form. I think a lot of people will rather opt for a sulforaphane supplement than broccoli. And then there is taurine. I use taurine very extensively in my practice, very successfully. Helps a lot with exercise recovery, but also exercise performance, helps with bile flow, it helps a very important role in heart health, and then also helps to bring down cortisol levels and increase GABA, your relaxing neurotransmitters. So there's various factors to contribute. So sulfate, the only way where we can contribute sulfur is through our diet or then supplementation.
Just before you go into depleting aspects of sulfur, if somebody's a vegan, Heidi, you've made it very clear that the best sulfur sources are from animal protein. But if we've got a vegan, do we just need to educate them on protein combining to get the complete amino acid profile and as much diversity as possible, and potentially supplement them when we feel they need the top up?
Yes, that's correct. That is going into looking at factors what will deplete sulfate. So the number one is a diet low in protein, like a vegan or vegetarian diet. Low in animal protein will have low sulfur coming into the system. So there we would concern definitely supplementation. But I think the other important factor is then minimize factors that will deplete sulfate. So, and in through a varied diet, all food has some degree of sulfur in, and especially if it's fresh, whole food. So processed food will be devoid of any vitamins and minerals and nutrients. So to make sure it's a whole food diet and a varied diet, if it's somebody that's a vegetarian, vegan, but then also to minimize things that will deplete. And that, like I said, will be over-processed food, because we need to realize if we eat that energy sport bar, which is quite high in sugar, that sugar needs to be catabolized and broken down and converted into energy. But for all those chemical reactions, we need nutrients, which is not in the energy bar. So that's what we call our empty calories. So it will give energy, but it will not give the nutrients that we need to metabolize it. And that means it will take it from other places in our body. First place would usually be our skin, first sign of aging, then our bones, and then we create just such imbalances. So steer away from over-processed food, because that will draw, and especially our micronutrients, which is this very important cofactors. Now, like I say, especially with athletes, there's a lot of stimulants and quick fixes and energy drinks and gels and bars and sport drinks, but they're usually very high in colorants, preservatives. And I think we need to see, as an athlete ourselves, as a Formula One race car. So that Formula One Ferrari needs a lot of petrol, good quality petrol. But if you have that race car, you're going to make sure you put the best grade of petrol into that car. But then the oil in that engine is also very important. So the petrol would be your macronutrients. That will be your carbohydrates, fats, and protein. But the micronutrients is the oil for the car. And then if we look at all the colorants and preservatives and things that we get through our diet, that would be like a spanner in the work. That will be dirty petrol or dirty oil in that engine, and it's not going to be good combustion. So we really have to realize that these unnatural, man-made colorants, flavorants, preservatives, additives that's added to food is going to mess up with our physiology. So to limit that. And then to look at other stimulants like caffeine. So most of these energy and even vitamin drinks and is loaded with caffeine. And caffeine, again, the body needs to metabolize, detoxify, break down the caffeine itself. And for that, it needs nutrients, which is not usually in the product. And also the N-acetyl transferase. And N-acetyl transferase enzymes, we need cysteine as a substrate, which is needed to metabolize caffeine. So if you have that caffeinated drink or bar or coffee, you are going to deplete more cysteine, which is such an important key factor in the sulfur pool from your system. And then alcohol, the same thing. So after a rugby game or any sport event and enjoying that beer, we need to realize that is also, the alcohol itself has to be metabolized and detoxify, and the nutrients is not in there. So it is going to deplete macronutrients and the micronutrients. And it's for this whole sulfur pathway, we need the sulfur, but we need all those micronutrients as well. The protein is, like I said, is like the petrol for the car. So if your car runs low on petrol, it's just going to not perform so well, or it's going to come to a halt. And it's going to stand still, but you can then fill up that car again. So that's your proteins, your carbohydrates, fats. But if your car runs low on oil or completely run out of oil, it will seize that engine. So that's when disease set in. And then we look at sudden deaths in athletes, because we see so many athletes that's perfectly performing and doing well, and then it is what the name is saying and implying, is that sudden death during a sporting event or even after. And so we need to realize it's that we fill up the petrol, but we don't look at the oil gauge and that oil running low. And then, like I say, that is when that car completely, the engine seizes. And then there's a lot of drugs and medication that's used in sport. The number one is most probably non-steroidal anti-inflammatory drugs, because of injuries and sport injuries, and for short term, but sometimes for a long period of time. And they are known to deplete a lot of sulphate. So all these drugs and medication need sulphate specifically to be metabolized and detoxified. And a pain medication like aspirin also cause more sulfur losses. And then another pain medication, acetaminophen, that's our paracetamol, within 2 hours of taking acetaminophen or a paracetamol, will deplete all the sulphate from your liver. So we don't realize that these medications cause massive sulfur losses from our system. And then there's the recreational drugs and even smoking, because smoking produces a lot of free radicals, so that will deplete a lot of glutathione, and that has an inhibitory effect then also on sulphation. And then other stimulants like our vitamins, all amine groups also need sulphate to be metabolized. Then there's other performance enhancing drugs like your anabolic steroids, so synthetic testosterone. So hormones also need sulphate to be metabolized. So sulphate is two main. Sulphate helps protection and all those physiological functions, but it's such an important role that it plays in detoxification. If we look at what is detoxification, it's usually all these molecules that I'm mentioning here, and these drugs are fat soluble. We need to convert them to water soluble so that we can easily excrete them through the feces or urine. So they need to bind on sulfate to be able for the body to metabolize them. So testosterone, being a hormone, is also going to deplete sulfur. And then a lot of athletes use diuretics to maintain weight, to lose weight and maintain a certain weight, or to mask doping. And that will also cause a lot of sulfur and macronutrient losses, and then dehydration. And then another important aspect is vaccination. So with vaccination, they're actually designed to cause inflammation, so inflammatory response, adaptive immune response, but that also has a negative effect on innate immunity, but cause a lot of oxidative stress, especially our new generation DNA and mRNA vaccines. Because so if we look at the mRNA vaccines, they use lipid nanoparticles to protect the genetic material. But it's known that the biggest cytotoxicity of nanoparticles is oxidative stress. I have written a paper on specifically the adverse events that we see after vaccinations. And unfortunately, we've seen a lot of sudden death in athletes since these vaccines has been rolled out. And this paper is explaining it all at length. The paper is currently in press, and it should be appearing or published online before the end of this week. So we'll make that paper available on the website with this video, because everything that I'm explaining here, it explains it just in much depth and detail. But vaccination also is unfortunately increased inflammation, oxidative stress, and the higher oxidative stress, it means it will deplete more glutathione, which negative impacts then on sulphation.
Thanks, Heidi. You've said a lot there, and a lot of this keeps coming back to, are we nourishing the body or are we depleting the body? And as I kind of sum up there, I would say man-made unnatural factors that come into our body in some manner are generally depleting because we need to detoxify it. And you were involved in the detoxification chapter in the textbook that I'm working on at the moment, textbook of integrative sport and exercise and nutrition. And I think we need to make clear here that detoxification is a process in the body. It's a biochemical process. Whereas a lot of people think of it as, a fad diet to try and lose weight. It's just a physiological biochemistry process that needs to be supported. And then anything, natural and unnatural in the body, hormones are a natural thing, but they need to be made, used, and then detoxified. And we need these processes working well to do that. And then when you compound with unnatural products, it makes it worse. So I did a webinar a few years ago, it might still be online, DIY sports drinks that nourish and not deplete. And it's exactly what Heidi was just talking about there when we're introducing sweeteners, colorants, flavorants. These all need nutrition or nutrients to detoxify. So whereas if we can make our own DIY drink out of a pomegranate juice or some kind of berry extract or grape juice, that can really support the body in a much better way. Okay, so Heidi, you've given us a lot to think about. We're talking about sudden death. Can you go into a wee bit more depth on the connection of what you're talking about here today, sulphation and obviously related pathways, and why athletes are falling down dead?
I'm just going to elaborate on what you've just been saying about detoxification. So to realize we need that detoxification for endogenous, molecules. So that's our hormones and neurotransmitters, and all these molecules needs to be also broken down and metabolized. But then also whatever we take from outside, so our drugs and medications and preservatives and colorants, is going to put a stress on these detoxification pathways. And I think this to look at it as a bathtub, so we fill that tub, but then if we have the tub open at the bottom, then it's going to be a draining, and it's sort of like to make sure that we don't have factors draining, and that we have mostly full, through good processed nutrition, good whole food nutrition, that we keep that sulphur pool full. So that is that contributing and what's depleting, and to keep that balance and to keep it in mind. But to look at specifically sudden death and how that's going to relate within athletes. So we want that sulphur pool full because we want to optimize sulphation. Now, heart attack is the main cause of sudden death during athletic performances, or even afterwards. So we're going to focus on the heart disease, heart attack. But there's many cardiovascular conditions and other factors that will contribute to the end result, which is a heart attack. But in this talk, we're mainly going to focus on myocarditis, which is inflammation of the heart. And myocarditis is the third leading cause of sudden death in young athletes. And it's also known that oxidative stress is underlying myocarditis. So inflammation will lead to oxidative stress, and oxidative stress will aggravate inflammation. So there's a direct relationship between inflammation and oxidative stress. Now, there's this research study by Bill et al. They found that the female-male ratio of sudden cardiac death among athletes is 1:9. So for every one female, there's 9 males that will die of sudden death. So it's a much higher incidence of sudden death in male athletes. And we also see myocarditis is much higher in young males. Even also in vaccination, we've seen a lot of myocarditis in young males. And one of the reasons is during puberty, there's a 20-fold increase in endogenous testosterone in males. So adolescents have very high testosterone levels. Now we know that testosterone needs sulphate to be metabolized. So there's going to be a high need or depletion of sulphur or turnover of sulphur. But also if we look at male athletes, they had high testosterone levels, but then it's also more likely that there's alcohol use, smoking, recreational drugs, and then other medications that's used, or like I said, that will deplete sulphur. And then like smoking will also have an effect on glutathione. So sulphate and glutathione will be low. And this alter the redox status and make one more prone to oxidative stress. And there's less sulphate. Then, like I say, because of higher oxidative stress and less sulphate, that will hamper steroid hormone sulphation. So like I said, testosterone needs, so there's higher testosterone, it will need sulphation to metabolize them. But if there's also use of alcohol and smoking in other medications, there's low sulphate. So we don't inactivate that testosterone, so testosterone is high. Also DHEA, that converts to estrogen or testosterone, needs to be inactivated by sulphate. And if that becomes desulfated, so under inflammatory conditions, we also then desulfate, or sulphate has been low from the start go, then the DHA will preferentially convert to testosterone, further increasing testosterone levels. So sulphation detoxifying, but especially for the hormones, it also helps to inactivate the hormones so that they're not active. But testosterone will deplete glutathione levels, and it's also known that in males has lower glutathione levels than females. Now, it's also just when there's high oxidative stress in the heart, it will cause cell death. And it's important to know that only 1% of our cardiomyocytes can turn over annually. So over lifespan, we can only 50% of our cardiomyocyte, our heart cells, can be recuperated, or we make new cells. So it's very hard. So we don't want to have cell death or any injury to the heart, and that's why we want to keep inflammation and oxidative stress as low as possible. Now, during endurance exercise or a sporting event, there's a lot of oxidative stress free radical release, which will deplete glutathione and cysteine. There's a study done by Sen where they found a 50% decrease in blood glutathione levels in moderate trained men during the first 15 minutes of exercise. Now, I know this is also very controversial because there is studies done and say moderate exercise will boost our glutathione levels, but one has to look also how that study is done and when it's been measured. But initially, the body will favor glutathione. If during exercise, the body will favor cysteine to produce glutathione to inactivate all the free radicals. But that will have a negative impact on sulphation. But definitely also during long endurance exercise, it is known that glutathione levels are very low. And during stress and high oxygen requirement, during intensive exercise, hypoxia sets in. And then we know, like I said before, under hypoxic conditions, cysteine convert to hydrogen sulphate as the emergency electron donor for energy production, for ATP. So there's an increased demand for cysteine during exercise to convert to glutathione to inactivate the oxidation stress, to convert to hydrogen sulphate as the emergency electron donor. But then there's less cysteine that can convert to sulphate. So that's going to have a negative impact on sulphation. So cysteine acts as a rate limiting factor. Now less cysteine, less sulphate, so there's less sulphation of the endothelial glycocalyx. So like I said, the endothelial glycocalyx line all the arteries and veins within the heart. Now, low sulphation of the endothelium will cause then a hyperinflammatory response. Remember I said that sulphate is important to modulate the inflammatory response. It will cause vascular permeability. So that protective glycocalyx layer helps that there's no permeability leakage, edema forming. It plays a very important role in coagulation and mechanotransduction, so the flow through these arteries. And then also low sulphate will lead to nitric oxide abnormalities. So that set the stage for a heart attack. So with low sulphate levels, this will be an microthrombi that can easily form. Low sulphation, so it means low redox status, also is increased during oxidation. So low sulphation and low redox station and increased oxidative stress during exercise is absolutely the perfect storm then for a heart attack. And increased inflammation and oxidative stress will also increase blood viscosity. So with thicker blood, it will also compromise circulation, but then it will be further exacerbated with dehydration during exercise. And then also, so dehydration will also then further compromise, and then also electrolyte imbalances will have a big effect on setting the stage for a heart attack.
Whoa, there's a lot there. And it's a pretty scary subject, but it's a real subject. You do have probably every big city marathon, you'll have somebody dying each year. You've got footballers dying on the pitch. Even golfers will keel over on the golf course occasionally. But the way you've presented it there, Heidi, means it's not just a chance event. There's a lot of, you've described it as a perfect storm. There's a lot of different factors that accumulate and build up. And it's not just happening now, it's a build up over time that then increases the susceptibility to that happening. So you've obviously talked about ways to support sulphation earlier, but what else should a practitioner working with an athlete be aware of? What should they be encouraging their athletes to do to try and just keep the cardiovascular system healthy? Because we're not just talking about sudden death here, we're also talking about cardiovascular pathology, which might not pick up till later in their life. And that's also something I presented on a few years ago with a webinar about cardiovascular pathology and like serial marathon runners and the likes. So what can we advise our clients, Heidi?
I just want to come in here with to bring it in another perspective. I use the analogy of a boat in the water, and in the hull of the boat there's maybe a small hole or a big hole. It might be a compromised gut system, gut health, or it might just be genetically there's a vulnerability. But then we load cargo on that boat. So it's not adequate hydration, diet, stress, and a lot of factors. But while that hole in the hull of the boat is above the waterline, the boat is afloat. So that athlete is still performing. But sometimes it can make a small little extra weight block that makes a difference whether it's above or under the waterline. So that one extra vaccination or that one partying or alcohol or that one anti-inflammatory, before an event can be that tipping point. And I see it in my practice with my clients. It's been okay. And there's always been in this one event that was just that tipping point with the body. And it's like I said, it's that car, we look at the petrol, but it's when that oil runs low and then that engine sees. And it's looking at that bathtub, to make sure that we contribute enough factors and that we limit of what we're depleting. And I think, especially as an athlete, you don't know, the human physiology is so complex, but that's why we have to simplify it from an external perspective and make sure that we only put the best into our body. So ask yourself, whatever you eat and ingest, am I giving to my system or am I actually depleting from my system? And we don't think of food from that perspective. And then all these other things that I've mentioned, that is depleting or draining. And I think we play a little bit of Russian roulette. You never know when that bullet is going to strike in a sporting event or even after. And I think people, it's this beautiful human physiology and what our bodies is capable of doing. But we are flesh and blood, and we need to put the right petrol and oil in that car. And I think as a practitioner, definitely to look at optimizing nutrition, and nothing that is still remains the baseline of a balanced whole food diet, but realizing the importance of animal protein, your whole grains, your pulses, and then loads of vegetables. But second to that, and that's what I find in my practice, is not people is dehydrated. They don't have adequate hydration. So to make sure that they properly hydrate themselves, we need about 300 milliliter of water per 10 kilogram of body weight. And in athletes, the need would be higher. But to note and realize that caffeinated drinks and products and high sugary drinks and alcohol will dehydrate the system. So to make sure we adequately hydrate, and then any athlete will know that micronutrients is very important in the diet. So to optimize electrolytes, micronutrients, to replenish, and then minimize the intake of medications and stimulants such as caffeine and performance-enhancing drugs. So to realize that they have a negative impact, and in that case, and if there's no other, if we have to use, say, anti-inflammatory drug, to make sure we support with supplementation, so like NAC or MSM or sulfur donating and supplements high in micronutrients to make up for those losses. And then it's rest and sleep. We focus all this lifestyle and dietary factors. So adequate rest, but with sleep to realize that we make melatonin, we optimize melatonin levels between the time of 10 in the evening and 3 in the morning. And we know melatonin is very anti-inflammatory, and it doesn't help to then to decide, but I'm just going to supplement in melatonin. We need to sleep those hours because melatonin is also a hormone. So if we take exogenous melatonin through supplementation and high dosages, that will deplete sulphur. So to make sure we get adequate rest and sleep and recuperate in those important early to bed, early to rise, and then to consider a personalized supplementation protocol. So there's a lot of biochemistry tests and DNA. I work with an advanced methylation DNA panel so that I know it's very advanced in methylation, but also the transsulfuration through to sulphation. Look at very important key enzymes and whether there's genetic SNPs. And then where there's weaknesses and compromise and how to optimize a supplementation program protocol for that specific athlete. And then, like I said, to bring it all together, to just look at how we can replenish sulfur in that micronutrient pool, but then definitely also how we limit those factors that is draining them.
Thanks, Heidi. So one of the things that impresses me about you is that you've got this passion with food, but then you've got a very sciencey brain on top of it. And you're in the middle of your PhD right now, but you're also involved in a farm-to-table project. So I think to finish this podcast, can you tell us a wee bit more about that? And just maybe emphasize the importance of food in all of this discussion we're having.
I think maybe the farm to table is just to get me away from my computer and research as a balance. But I think it started with my whole food recipe book that I wrote 20 years ago. I advise pasture raised, free range, organic, seasonal, sort of all. So it's my passion to be able to produce, to deliver and to make available those kind of food to my clients. And I believe it's very important to support farmers and our small-scale farmers who is farming chemical-free. They don't use vaccinations and antibiotics and growth hormones and completely chemical-free. And we also look at optimizing nutrition for the livestock. We have to realize that healthy soil leads to healthy plants, to healthy animals, and healthy humans. So part of my function is to educate and also farmers that they realize how important it is that they produce nutrient-dense food and how that will impact the health of their consumer. So that is another passion to make sure that we have good produce and healthy produce, and then that it's available and made available directly to the end user, and to cut out a lot of middlemen, because that middleman is usually processing and over-processing of food, and then also value adding and making food very expensive. But there's lots of different reasons why it's so important to look at our farmers, our small-scale farmers. We're in a very political area that we live in at the moment. And so it's a big drive and it's a big passion of mine.
So I think I'll be asking you back on for a podcast on farm to table, because it's a huge passion of mine as well. We can get stuck into the science and all the metabolic pathways, and it's very, very interesting. But some of the most powerful things that we can do with our clients is get them onto good, high quality food. So Heidi, thank you very much. If somebody wants to look you up or get hold of you, what's the best contact medium for you?
That's at the moment is email. So my email address is going to be with this podcast on your website.
Thanks, Heidi. I really appreciate the generous input of Heidi and all my other guests on the Health Feeds Performance podcast. To listen to or watch more of my interviews, subscribe to our YouTube channel or check out our audio podcast channels. I'm also really keen to know what you would like to learn. So please jump onto our website, intsportsnutrition.com, and let us know through the contact page what you would like to actually learn in the future. What more podcasts would you like to see? And while you're on there, have a wee look at our courses that we run. So, bye for now.